So what we have here, this is a Lego Mindstorms robot. And basically I want to do kind of a quick demo on some of the sensors and some of the inputs. Up here I have the screen on top there. So it shows you different values that it's receiving. So there's a sonar value up here and then steering value. So like what Ron was showing on the front there. I can go ahead and get the value, how far away it is. You see on sonar?
Yeah.
And then 255 is when you can't read it. This gets too far away or too close to it. But you can use that to figure out how far the robot is and not to crash into the wall that's on there. The robot itself is just built off of standard parts. I mean, any child can build this. It's not that difficult. The only thing custom in here is a circuit board for the joystick. It's also not I ordered off the web for that. And if I want to go ahead and steer it, you see here on the top, the steering. So that's the value that the joystick is reading. And then for my steering back and forth, it's on there. So you see all the inputs is forward, 99, negative 99 is my control for it. So it's really easy as far as to run it. And then right behind there I put a real simple program to show you kind of what's involved. So let's go ahead and step into this. Roll away. Start there. Step into. All right, so what we're doing here is we're going to walk line by line through this program. So we have here, it says motor, this is motor C, and then motor B. Those are my two ports on the robot. So right now I'm going to go ahead and take the motor C to 100% power. Then go ahead and step through it. Go here, step into. So I'm going to go ahead and run that one motor at 100%. I go to the next line. Now both motors are going. So just walking through the code to control the motors. And then the next one here is basically go backwards. So one's going the opposite direction. You see that? And then go ahead and stop it. So controlling the robot is fairly simple. Do a couple commands. There's some more advanced things on here. We go up to so this is an example of figuring out your speed. So this is basically a program. The unit itself can run up to 20 programs at the same time. So you can run special tasks and pull down the values. So here I have my motors. Basically I'm pulling a value where my motor's at, because there's an encoder on the motor, so it knows exactly in space where the motor's at. So basically I want to grab a value, wait a couple seconds, and grab it again. And that tells me exactly where my motor is and how fast it's going. Now, an application of that is there's a calibration program on this. So let's bring that one up. So what it's going to do is it's going to move the wheel here, find out the encoder value, move it until it goes across, find it again, and then center it. Now what it knows at the end, it knows if the motor is not moving. So it does that speed check. So okay, I'm not moving anymore, go the other direction. That's a simple calibration for it. So we can take this guy here, grab around. Oops. Now if I try and bring it to the wall here, it should stop. There it goes. So it won't go forward. Cool. And that's basically it. I put in some extra motors here to run the engine on the front and some lights. So we have LEDs on the front and the back for that, for show.
Could you talk a little bit more about this development environment you've got?
Sure.
So it's got live debugging.
Yeah, this is Robot C. There are multiple environments for the Lego. You can write it in Java, you can write it in Lua, you can write it in what's called NXTG, which is a graphical interface. So you have a block for motor and a block for movement and sensors, which I can show too. But this one here is basically Robot C, which is ANSI C.
So is the next remote screen part of Robot C?
Yeah.
Is
that you buy that package? Or-
Yeah, well, the program's $30.
Okay, $30. Wow.
Yeah.
And you might want to mention that it was written by a DPRG meeting.
Yes, Dick Swan helped write this program here. So let's bring this up again.
And the controller, what do you spend for that?
Well, there's a basic kit for Legos. It currently runs $280, and that gives you the controller, 3 motors, gives you a distance sensor, actually two touch sensors, and a microphone, and
And a whole bunch of parts.
a whole bunch of parts. Yes,
Okay, so
definitely.
that, you're pretty much that, and the $30 for the C, you're good to go for about $300.
Right. This is actually 3 separate kits built together,
Okay.
so it's quite a bit more than what the default kit comes with. But you can build a reasonable robot with the default kit.
The new Next kit has a different set of sensors, by the way. It doesn't have a
Yeah.
microphone anymore. It has a
Okay.
color sensor instead.
That's right, color sensor.
Yeah.
Right, the old one had a black and white sensor, the new one has a color sensor. That's right.
Yeah.
And the new one comes with tracks. Is the other thing, road tracks.
That's cool. What's the microphone for?
Oh, it was for doing decibel levels, so you could clap, and it would understand that.
And then also the hardware on the NXT is it's like an ARM with a few Atmels, like Atmel 8-bit micros, and you can, because I want to say Dale, like you drill a hole in the side and you can solder onto the JTAG header, and you can program it directly with GCC. So if you don't want to, because Robot C is interpreted technically, but like if you want to program it straight in C, you can do that, and it also has Bluetooth.
Yes.
That's a whole other thing that's not even on here. Is that the NXT's got Bluetooth built in, so you can control it from your phone or whatever. It's a pretty good. It's always my answer when someone says, "Oh, I have a kid, I want to get started in robotics." I'm like, buy the NXT. It's in the end, it's the best buy, and it's easy for kids to work with. So.
Right. And of course, with the software, you can control it. You don't have to actually buy a joystick. You can just plug a joystick directly into your laptop and use Bluetooth to control it. This is an option. They don't have to have my computer on to actually route around.
It is a Bluetooth joystick.
Well, it's Bluetooth because the receiver it's a regular PS2 joystick. We happen to use Bluetooth, but it's not Bluetooth in the sense that it's going to work on the computer. So 2 separate issues right there. And then as far as power goes, basically, it's got 6 AA batteries. There is a rechargeable battery available for this. I don't have one. And then additional 6 batteries that run the additional motor that's in the back. So, any questions?
Oh,
Sorry.
so when you write this C code here,
Mhm.
does it, as you go, does it tell you, oh, syntax error? Or
Yeah, it does. There's basic intelligence in the software.
Okay.
So if we go here, for example, I do motor, it'll come up and it'll show me different stuff. So I can go down here to motor, and then I go bracket, and then it's motor, look here. Oops, it's wrong.
And that's the Robot C doing that?
Right. So they give you some syntactic help to write it out. And it also keeps track of all the variables. If you notice too on the side here, the global variables. So when we run the code, it'll actually list all the variables here, and you watch them in real time as they're on the list.